Hello, so today we're going to be having a look at this question. If you want to read it all, you can just pause it. Um, it's 2013's relative velocity question from the leaving cert. So what I've just done is drawn out the velocities or the um, paths of both of the cars and the speed they're going at, and they're both 90 meters from the intersection point. So A is moving at 9 meters per second and B is moving at 15 meters per second. The first part is to find the distance between the cars when B is at the intersection. So that's easy enough. It's just 90 minus 9 by 90 over 15, because it's 9 by 9 meters per second, which is what A is moving at, by the time it takes B to get to the intersection, because B is moving at 15 meters per second, so it'll be there first. So there'll be 36 meters from they'll be 36 meters apart when B is at the intersection, because B gets there first. So now for part 2, we're trying to find the shortest distance between the cars. We're trying to find the value of theta, the angle between them. So we can write the velocity of A as 9I plus 0j, because it's not moving up or down, it's just moving straight to the right. And then the velocity of B, we can write as 15 cos theta minus 15 sine theta, because as you can see there's the angle theta. So if you just draw a triangle down, the velocity of B going down or across is going to be 15 cos theta, because it's the because it's the adjacent of theta over the hypotenuse, which is 15, and minus 15 sine theta, because that is the value of it going down. It's moving downwards, and it's the opposite, so it's opposite theta over the hypotenuse, so it's the side that's opposite is what's going down. So then you can get velocity of AB is equal to VA minus VB. That's basically if you put B in place and have its velocity relative to A, so only A is moving. So you take one from the other, and you get 9 minus 15 cos theta I plus 15 cos theta j, because it's minus 15 sine theta. Or I've written cos theta there, but it is sine theta by accident. I just did not realize. Sorry about that. So now the important thing here is that the velocity of AB is perpendicular to the line AB, because 36 meters, what we found earlier, is the closest they get. So they never get any closer. So the line of A relative to B is perpendicular to AB, because B is not moving and they're at their closest point. So they're only going to be moving away now, so they're completely perpendicular to the line of AB. That is the one key thing to remember in a question like this. So then, because of this, you can write 9 minus 15 cos theta is equal to 0. So yeah, I'm just saying that they're only moving away now. There's no moving closer. So 9 minus 15 cos theta is equal to 0. And then you can easily enough solve for theta because of this. So you're going to say 9 is equal to 15 cos theta, and then get the cos inverse of 9 over 15, or 3 over 5, and you get 53.13 degrees. So now to move on to the second part of this question, you're trying to find the direction in which the airplane P should fly to intercept Q. Now Q is flying at 600 kilometers per hour due east, and you're trying to find the angle that P needs to set off at, and they're at 30 degrees from each other at the moment. So you're trying to find the angle that I've just traced out there. That's the angle that P is going to set off at for their interception to happen. So the velocity of P, I'm just going to draw out a small triangle to show P here. So P is there, and it's going to move off that angle alpha that we're looking for at 600 kilometers per hour. So its velocity is going to be minus 600 cos alpha I, because it's moving to the left, and cos alpha because it's the adjacent component of alpha, so minus 600 cos alpha I, and its j component, because it's moving down, is only minus 600 sine alpha j, because it's the opposite to the alpha. Sine is opposite over hypotenuse. And then the velocity of q is, I'm just explaining that in the video there. So the velocity of q is just straight up 600 I, because it's just moving straight to the right. It's positive, because just it's moving to the right. So then, just as earlier, velocity of p relative to q is minus 600 cos alpha minus 600 I. So you just take one from the other. So the 600 becomes negative, and the negative 600 cos alpha is already negative. Minus 600 sine alpha j, because you're not taking any thing from the q from the p from the q, because there is no j component in the velocity of q. So then you can see the next part is that you have this angle 30 degrees, and because q is perfectly still, and you have the velocity of p relative to q, you can say that tan of this angle 30 is equal to the amount that p is moving in the j direction, so the opposite, over its adjacent, which is 600 cos alpha plus 600. You change all the positive, it's the same positive and negative. So 600 sine alpha over 600 cos alpha plus 600. That's just because q is perfectly still when you're doing velocity of p relative to q, so it's just the p component. So it's basically a still triangle now. So tan 30 is root 3 over 3, and you divide the right side by 600, so you're just left with sine alpha over cos alpha plus 1, and then multiply across, and you get 3 cos alpha is equal to, I've forgotten the root 3, because it's root 3 by 1 as well, so it's plus root 3 plus root 3 cos alpha is equal to 3 sine alpha. So then if you divide everything by root 3, you'll find that cos alpha plus 1 is equal to root 3 sine alpha. Just going to write that out there. And then I messed up this line. I only noticed in the post, which is why I'm recording this over rather than using the original audio. So I'm just going to cross that out in a second. When I was looking back over my notes, I got that wrong, so I'll just pick it up. I cross that out and pick it up from there. So yeah, the next step is square, because we just got the squared it wrong. So yeah, you square both sides. You get cos squared alpha plus 2 cos alpha plus 1. So a squared plus 2ab plus b squared is equal to 3 sine squared alpha. So when you square root 3, you get 3 and sine squared alpha. And then the next step is to remember that sine squared is equal to 1 minus cos squared. So you'll get cos squared alpha plus 2 cos alpha plus 1 is equal to 3 times 1 minus cos squared alpha. So that's something you'll find in your log tables, but it's just handy to remember that sine squared a plus cos squared a is equal to 1. And you can always use it to manipulate to get, because once you have everything in terms of cos or in terms of sine, it's easier to work it from there. So then bring everything onto one side, and you find 4 cos squared alpha plus 2 cos squared alpha minus 2 is equal to 0. Then you can divide by 2, and you get 2 cos squared alpha plus cos alpha minus 1 is equal to 0. And then you let cos alpha equal some constant. I just used t. This is just for the sake of ease when you're doing a factoring. I'm running out of space on this page, but let's keep going for a couple more lines. So you've got 2t squared plus t minus 1 is equal to 0. So I've just written out what I had before, but with t equaling cos. And then to factor that, it's 2t times t and plus 1 minus 1, because then you'll be left with plus 2t minus 1t is just t, and plus 1 times minus 1 is minus 1. So I'm just going to move up there for a second. And you can write, so 2t minus 1 is equal to 0. So then t is equal to a half, or t is equal to minus 1, and you can discard that answer, because then you're going to get an answer of 180 degrees, which is just it going backwards. So that answer obviously doesn't make sense. So you find that cos alpha is equal to a half, thus alpha is equal to 60 degrees, and it's moving west and south, so it's moving to the left now, so it's west 60 degrees south, or you can also write that as south 30 degrees west. Once again, thank you so much for watching. I prefer writing these questions out by hand for these sort of questions, just because it's faster than doing the animations, and I'm going to tend to stick to doing the animations for the theory side of things. But if you do have any comments or suggestions, just throw them down below. I'm enjoying doing these videos. I'm going to get better at them over time. I'm far from perfect, but yeah, thanks for watching. So like and subscribe if you want to. Thanks very much.